Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Ainun Madihah. Today I will explain the solution for part A question 1A and B based on the investment problem given. For question A, Amira invested Rm50,000 in an investment scheme for 20 years. The investment rate offered 4.5% compounded quarterly for the first 7 years and 6% compounded every 2 months for the rest of the period. Find the future value. The scheme offered two different interest rates of the investment period. 4.5% compounded quarterly for the first 7 years and 6% compounded every 2 months for the remaining 5 years. Our goal is to find the future value of the investment after the full 20 years. For the first 7 years, the interest rate is 4.5% per year, compounded 4 times a year. Then we use the compounded interest formula as equal P bracket 1 plus I power of N. So the periodic interest rate is I equal Kn equal 0.045 over 4. The number of compounding periods N equal MT equal 4 bracket 7 equal 28. Substitute the values as equal 50,000 bracket 1 plus 0.045 over 4 power of 28. So the accumulated amount after 7 years is as equal Rm 20,577. Next 5 years, 6% interest per year, compounded every 2 months, meaning 6 times per year. Periodic interest rate I equal 0.06 over 6. Number of compounding period is N equal 6 bracket 5 equal 13. We use Rm 20,577 as the new principal. Subtracting the value is S equal 20,577 cent bracket 1 plus 0.06 over 6 power of 30. The future value after 20 years is S equal 27,654.85 cent. Therefore, after the full 20 years, Amira's investment grows from 15,000 to 27,654.85%. Show two different compounding rates. Now I will explain question B. 5 years ago, Adam saved RMX into an account offered an interest rate of 4.38% compounded monthly. Find the value of X if now the total amount in his account is 2,426.45 cents. First, the monthly interest rate is I equal 0.0438 over 20. Next, the number of compounding period is N equal 20 bracket 5 equal 60. We use the compounded interest formula, but this time we rearrange it to find the principal. P equal S over bracket 1 plus I power of N. Subtracting the value, P equal 2,426.45 cents over 1.2443 equal Rm 1,950 ringgit 5 cents. So Adam originally saved it.
Next, we move to question 2. Read the question carefully and understanding the question. For this question, we use the compound interest formula. To get the solution, we should find the amount of interest per compounding period and number of compounding period. The interest is compounded semi-annually, so the interest is applied 2 times per year. Next, we convert 48 months into years. 48 months equals to 4 years. Since compounding happens twice per year, N equals to 2 times 4 equals to 8. So 8 is the number of compounding period. Now we need to substitute all the things into the formula, and next we move 15,000 to the left side to divide by 38,635 ringgit and 71 cent. After that, to get rid of the power of 8, we take the 8 root, then subtract with 1. Lastly, multiple it by 2. Because of the rate in percent, so we should multiply the answer into 100%. So this is the final answer. We move to question 2B. Read the question carefully and understanding the question. We should write the formula, and this is the formula. Next, substitute all the keyword into the formula. The interest is compounded quarterly, so we divide the annual rate by 4, so it becomes 0.0175, and quarterly compounding means N equals to 4T. So this is the equation. After that, we divide 87,110 and 67 cent by 15,000. Then after we got the answer, we need to use log or ln as a problem-solving solution. So we put ln in front of the equation on the left and right side. Then we put the power in front of ln. Then divide it on the right side. So this is the final answer. We got 8 years as the number of compounding period.
Part B, question 1. A. Harry borrowed Rm50,000 from a bank which charged 50% compounded monthly. He paid the loan by making 48 monthly payment. Find his monthly payment. For this question, we can use the formula A equals R multiplied by open bracket 1 minus open bracket 1 plus I close bracket raised to the power of negatives and close bracket all divided by I close bracket. As we can see, A represents the present value, R represents the periodic payment, and I represents the interest rate per period. For the value of I, we use K divided by M, where K is the nominal interest rate and M is the number of time the interest calculated in 1 year. The variable n is equal to m multiplied by t, where t is the term or length of time in years. So we list the value as follow. A equals 50,000 ringgit. R is unknown because we want to find the value of R. I equals 0.05 divided by 12. N equals 48. Next, we substitute all the value into the formula. Then we rearrange the formula by moving R into the front, giving R equals 50,000 ringgit multiplied by open bracket 0.05 divided by 12 close bracket, and then divided by open bracket 1 minus open bracket 1 plus 0.05 divided by 12 close bracket raised to the power negative 48 close bracket. After that, we can calculate the value using a calculator, and the final answer is 1,151 ringgit and 46 cents. B. Darren wished to accumulate 400,000 ringgit by making payment of 7,500 ringgit at the end of each quarter. If he gets 60% compounded quarterly on his money, how many regular payment will he make? So for this question, we use the future value annuity formula, which states the future value equals the regular payment multiplied by the expression consisting of 1 plus the interest rate to the total number of period minus 1, or divided by the interest rate. Next, we substitute the values given in the question. We let the future value be 400,000 ringgit, the regular payment be 7,500 ringgit, and the interest rate be 1.015. After substitution, the equation becomes an expression that simplified to 1.84 when 1.8 when 400,000 ringgit is multiplied by 0.015 and divided by 7,500 ringgit. This isolate the expression containing 1.015 raised to the power of the total number of period minus 1. Then we add 1 to both sides of the equation, which result in 1.015 raised to the power of the total number of periods being equal to 1.8. Because the total number of the period appear as an exponent, we use natural logarithm to bring it down. Taking the natural logarithm of both sides give the periods equal to the natural logarithm of 1.8. By applying logarithm rules, we rewrite this as the total number of period multiplied by the natural logarithm of 1.015 equal the natural logarithm of 1.8. To find the total number of period, we divided the natural logarithm of 1.8 by the natural logarithm of 1.5. The natural logarithm of 1.8 is approximately 0.587787, and the natural logarithm of 1.015 is approximately 0.0148886. Dividing this value give approximately 39.48. This means Darren would need about 39.48 quarterly payment. Since the number of payment must be the whole number, and because he cannot make a fraction of a payment, we round the value up to the next whole number. Therefore, Darren must make 40 quarterly payment in order to exceed to target amount of 400,000 ringgit.
This is the last question for set 5. Question 2, 1 Robin. We need to calculate the monthly payment. Read the question carefully and understanding the question. So we need to find out the amount of loan. Amount of loan is 585,000 after paid 10% down payment. Next, we need to substitute all the things into the formula. Then divide the answer from bracket solution by 585,000 to get the monthly payment. So the monthly payment is in R. Our R is 3,419 ringgit and 85 cents as a monthly payment, and that's the answer. Next, we move to question 2 to Roman. For this question, we need to find the amount he had to pay on the sixth payment to settle outstanding arrears. In this situation, the monthly payment is R equals to 3,419 ringgit and 85 cents. The monthly interest rate is I equals to 0.05 over 12, and the number of missed payment is N equals to 6. Then we need to substitute these values into the formula given. Lastly, we need to calculate the amount of R multiples by the bracket with the bracket solution. Then we'll got the answer. So the answer is 20,734 ringgit and 3 cents. This is the last question. For this question 2, third Roman, we need to calculate outstanding balance paid. For the balance payment, we got 60 as a balance payment. Next, we need to substitute the values into the formula. Lastly, the monthly payment multiple to the answer from bracket solution, and 181,220 ringgit and 27 cents is the answer, and that's our final answer.